Okay, cool. So program synthesis, the task of automatically generating a computer program that satisfies a high-level specification, has been an active area of research since the inception of artificial intelligence. This field has applications ranging from biological discovery, code generation, to program repair. However, despite its broad utility and years of active research, existing systems predominantly focus on single-user interactions. While these single-user systems have their merits, they overlook a crucial aspect. Software development is often a collaborative team effort.
Sorry, Tyler, one moment. Sorry, we have to fix something here. Okay, sorry, proceed.
Okay, no problem. Okay, so single user tools have their merits, but software development is often a team effort. So software engineering typically requires a collaborative effort. In fact, a team typically comprises several roles, including software developers, quality assurance engineers, and project managers, as highlighted by research from Whitefield et al. The value of collaborative practices has even been supported by empirical evidence. Studies such as those conducted by Binker and Korkala indicate that collaboration positively influences aspects like communication, creativity, and ultimately the quality of software. However, limited work has been done on the application of program synthesis in team-based settings, where these tools may present a unique set of challenges and advantages. Furthermore, existing studies have yet to fully explore the nuances of how teams use and interact with program synthesis tools to complete tasks. We hypothesize that this disconnect between tool design and the collaborative nature of software development creates a gap in the effective application of program synthesis tools within team environments. We also hypothesize that addressing this gap could result in the development of more effective, team-friendly program synthesis tools, potentially improving the robustness and corner case handling abilities of synthesized programs. This is particularly pertinent as recent studies suggest that individual users grapple with providing comprehensive specifications, including input-output pairs. Cool. So in this presentation, to explore this potential gap, we propose two study designs with three primary objectives, which I will go over now. The first objective is to uncover the unique limitations and challenges that teams encounter when using these tools compared to individual developers or end users. The second objective is to identify any emergent best practices or strategies that teams employ when collectively generating specifications to describe the desired program behavior. And finally, the third objective is to examine the techniques that teams employ for collectively evaluating and iterating on the synthesized programs, or the candidate programs. Okay, so jumping into the first study design. This is a between-subject study. The study will involve a total of 24 participants to be recruited from university computer science departments. The sample will be diverse in terms of grade level, ranging from undergraduate to graduate students, and potentially from different educational institutions. How the participants will be selected is to be determined, but it will likely be on prior experience with programming languages, or certain programming languages and projects. In this study, participants will work on two tasks from predefined hackathon-style challenges. They will use a single user synthesizer or just a synthesizer for one task and will not have access to a synthesizer for the other task. The participants will either work in pairs or individually to complete these tasks. The aim or the goal of this is to tease out, one, the impact of the synthesizer, as well as the impact of working in teams with a synthesizer. Just a couple notes on the style of questions. We hypothesize that choosing hackathon-style questions for the study offers a couple methodological and practical advantages. First, the time-bound nature of these tasks introduces an element of urgency that may reflect time constraints commonly found in real-world software development. Second, hackathon tasks are typically designed to be collaborative, aligning with the study's objective to examine group dynamics and interactions with the synthesizer. And finally, hackathon questions often require a blend of skills: coding, debugging, design thinking, which might enable a somewhat comprehensive evaluation of how a synthesizer can be integrated into various stages of software development. Okay, study design 2. This study will involve recruiting 4 to 5 existing software development teams or teams totaling 20 to 25 participants from various course projects. The teams will be selected based on their ongoing software development projects. In this study, rather than prescribing specific tasks, the study allows participants to work on challenges from their ongoing projects. These may include common software development tasks like bug fixing, feature addition, and code review. After an initial orientation and consent process, teams will be observed over 1 week as they tackle tasks using a synthesizer. A mid-week check-in will be scheduled to address any questions or challenges, and the study will conclude with a semi-structured exit interview conducted at the end of the week. Okay, so I'm now going to go into, I guess, some guided questions that I'd love for people to answer. I don't know if that's possible with audio stuff, so maybe I can just briefly go through them. But the upshot is that these study designs have some limitations, and I'm going to go through a couple that I think must be addressed before really conducting any user studies. One is, what can we glean from student projects? So in the second study design, I mentioned that we could have 4 to 5 teams, and the easiest thing would be to recruit these teams from courses at Harvard, for example. So a lot of grad courses have final projects, and they often work for about 2 to 3 months in teams of 2 to 3 to complete them. Okay, but the issue is that this demographic or these type of projects contrast sharply with professionals in long-term roles and projects. This difference could affect interactions with the program synthesis tool and limit the study's generalizability to professional settings. That being said, we recognize the benefit, yet challenges of including professional developers and early stage startups to possibly enrich the data and the feedback generalizability of this study. So that's one. What can we glean from that? Another is, what insights can we derive within 1 week time frame, or even from an hour-long laboratory study? The hour-long laboratory study is the first study design. So the second study lasts only 1 week, limiting our insights into long-term behavior until adoption. Additionally, it restricts our ability to assess the sustained impact on project quality. However, this study could still serve as a foundation for informing future and more extensive research. Sorry, that's a duplicate. Another question is, should we dictate how the synthesizer is used or observe the natural usage by the teams? Another question is, should we use a large language model to generate the candidate programs? And this is definitely something that we will have to think about quite critically. Given that large language models offer flexibility but lack formal guarantees, we believe that this could help us in discovering what types of specifications work best for different groups. And some closing thoughts are, generally the study aims to scratch the surface on 3 fronts. And actually, I kind of take this back. I think I hope to understand these 3 questions, and I think this study actually only scratches the surface on the first. So I'm really interested in this idea of group sense making in the context of program synthesis or using program synthesizers in team-based settings. So 3 things that I think have to be thought about and worked on are identifying the ideal specification types for groups, gaining some insights into how to guide the synthesis search algorithm based on group-based heuristics, and finally ranking the candidate programs based on group interest and needs, preferences. And again, I think this study would only scratch the surface on the first one. And that is it. Thank you for listening.
Testing? Okay. So we have to make sure we use the microphone for questions so Tyler can hear us. Comments? Yeah.
Thank you for the talk. I was wondering whether you could clarify a little bit on what you mean by hackathon-style questions. And my question is derived mostly because if you give someone a 30-minute task, how well could it be parallelizable versus someone just doing it by itself? And if you compare a team with synthesizer and team without synthesizer, wouldn't it make sense to also have a single person with and without the synthesizer to look for the team-based dynamics? Thank you.
Yeah, sure. So I should have came with a concrete hackathon example question, 'cause I knew this would come, or example, yeah. But to answer the second one for sure is, so in the first condition, I didn't quite make that clear, or the first site design, we are hoping to have 24 participants. 12 of them would work in pairs, and 12 of them would work individually. And regardless of whether you're in a pair or a single, or whether you're working individually, you would still go through two conditions. One condition would be solving a hackathon-style task without a synthesizer, and the second would be solving it with one. I actually did a pilot, 2 pilots over the past week, where like instead of doing hackathon-style questions, I did regular expression tasks. And it was the same two conditions. Yeah, every condition had a regular expression cheat sheet. And I think like I was starting to see some interesting things there, but I'm just concerned about giving such a narrowly scoped programming task.
Hi, since you're joining us virtually, I'll introduce myself, Jonathan Aldrich, Carnegie Mellon University. Really interesting talk. I'm really excited to see what your results are. Since you're thinking about design of the study, I was wondering what kinds of data will you gather in these studies, and how would that bear on some of the questions you're asking?
Yeah, so there's some HCI, I think it was actually from psychology. It's called critical incident analysis, or the critical incident technique. And pretty much you observe people and you either have them or you identify the incidents that lead to either a failure or a success. And what you define the failure as and success is obviously dependent on the study. Here it might be a couple things. One being like whether a program was synthesized that meets everyone's preferences and needs, whether a program that is efficient in some XYZ way is generated. So I think this will change, but it would be interesting to do some type of CIT thing where we can tease out some incidents that lead to the success or failure of really single user synthesizers in team settings. Does that kind of answer the question?
Yeah, I think so. So basically, at a high level, it sounds like you're going to be observing and doing some qualitative analysis that can lead to a deeper understanding of this. That sounds really interesting. Thanks.
Yeah, exactly. Thank you. Yeah, it's quite open-ended, which makes me nervous about the study, but I'm hoping to do something open-ended to guide pretty much the rest of the research during my PhD.
All right. Hi, I'm Will Creighton from Brown, and my question is that I'm curious between the pilot studies you've done as well as related results from collaborative software development. What kind of phenomena are you expecting to see? Like, are there certain things you would expect to see happen when people build these shared specifications? Or things you'd be surprised if they didn't happen. I realize you can't go in too expecting to see stuff because that defeats the point of open and qualitative analysis. But I'm just sort of curious if you have a sense from both your pilots and the related work of like what sort of stuff you might be expecting to look for.
Yeah, I think there's definitely two things. One is how much better the specification is compared to when a single user puts it together. So I expect to see more edge cases being specified or encoded in some way. That's one thing. And I was already starting to see that in the pilot studies. One thing that I didn't see in the pilot studies, and I think this is largely because of like the task that I was given, was conflict and how that's resolved either in the specification stage or in like the ranking stage of the candidate programs. And I hope that's clear what I mean by conflict. Like there might be a case, and I honestly haven't quite seen it yet, where some some group member wants X to happen and encodes that, but another wants like Y to happen, which kind of contradicts or conflicts the first requirement X in some way. So those are two things that I'm hoping to see in some way.
Got it. Thank you.
Imran.
Great talk. Thanks. I had a question based on your slide about large language models. I was curious if there's any existing work you're aware of in how using large language models interacts with code review and whether that might relate to your work or whether you're more interested in how people use the synthesizer in the first place rather than how they evaluate the output of the synthesizer.
Yeah, got it. Sorry, you said related work on language models for what? You just cut out for 1 second at the
Oh, sorry.
beginning, but I rest.
So people, engineers or people using language models to generate code and then how that interacts with the code review process. So like if you're going to be, you said you'd be interviewing teams like over the course of a week, I'd assume they'd be doing code review in that process. Is that something
Yeah.
that you're going to be studying or are you more interested in other aspects?
Yeah. I mean, I would love, so keeping it open-ended, I wasn't going to, how can I answer this? Okay, so I assume that when we give them a synthesizer, whatever form that is, or whatever type of synthesizer that is, that they'll do a couple of programming tasks on their own without me saying that, and I assume one would be code review. I don't know if that's completely answering the question, but I wouldn't necessarily require it because I kind of just want to see what they naturally decide to do with the synthesizer. But of course, that makes the analysis so much harder. There was one other thing I was going to say though. In terms of large language models, though, one thing I've been interested in and related work is like multi-agent systems and like how agents are now being kind of powered by large language models and things like that. And I think that may be a way to augment traditional program synthesis algorithms / LLM type stuff to do multi-user program synthesis.
Awesome, thanks.
No problem. Thank you for the question.
So, did you? Okay. So one thing I'm curious about is the sort of the range of different teamwork situations that come up.
Yeah.
So, teamwork, it ranges from people who are really working alone but with large teams, and so they're coordinating on tasks and they're agreeing on deadlines and deliverables and requirements and that sort of thing. But the actual development happens, in a solitary kind of way primarily, versus sort of a pair programming or even larger scale context where people are sitting at the same computer, working together on a task.
Yeah.
Which sort of situations are you focusing on, or are you looking at all of them in your study, and how do you think about that?
I think you cut out the end, but are you saying which situations am I focusing on, or am I going to just focus on all of them? Was that the end question?
Yeah, right.
Yeah, okay. So the pilots that I've been doing have mostly been like the pair programming, maybe with like 3 people instead of 2, and I don't think that's quite generalizable. So I think what I'm trying to find a medium between like a true like development software engineering team at a company, even startup, and that by maybe focusing on student projects and seeing how they do that for a 2 to 3 month or a week span, maybe eventually a 2 to 3 month span, because that's usually the typical time to do group projects. Yeah. I mean, ideally, it would be cool to focus more on like how a real team is doing it and maybe restrict it by the domain they're working in or like the size of the team or the goals. But I think for right now, I'm going to just focus on small group projects for the kind of initial foray into this.
Okay. I think it would be interesting to think about sort of how the team contribution process or teamwork process relates to the choices. So I could see sort of exploring a range of different teamwork configurations being interesting. John?
Yeah, that is very true. Yeah. I mean, that would be really nice. I think like one way I'm like backing away from doing that is because of my fear of doing the analysis, but I think I might just have to suck that up because I think the results would be really interesting if I did that.
Do you have, I see, you stopped sharing. Are there any other topics that you're hoping that the community can help you think about?
Sorry, any other topics that I've been thinking about related to this or just in general?
Well, if you're looking, I mean, this is sort of a more open-ended discussion because it's preliminary work. So if there are sort of things that you're hoping the community will offer thoughts on, maybe you could ask us directly your questions.
Yeah. I think I guess some of my two main things are ideas on who to recruit. I think you kind of just touched on that. Another is like whether I would just love to know people's thoughts on using a large language model to synthesize these programs. I did some pilots with a traditional synthesizer that generated regular expressions, Pythonic ones, and that didn't go quite well. So that's kind of why I'm leaning more towards LLMs at the moment.
Yeah, I thinking more about the large language model. Like I wanted to ask, I guess, a more pointed question, but I don't know. I was trying to read the room because I don't know how everyone feels about LLMs. Like my kind of view of the situation is like I like have worked with some like prototype research synthesizers in the past, and they're like really really hard to deal with. I assume that they've gotten better like since like the last time I touched them, which was like 3 years ago. But like I use large language models all the time, like every single day to write code, and like lots and lots of people do. So I guess I'd be curious, like in choosing between using classical versus contemporary synthesizers for this study, like what would be your motivations? Because like I could see like a motivation for using LLMs is everyone uses it, so you're studying like real things that real people use. Whereas maybe your motivation for studying classical synthesizers is you're trying to make them more usable so that they can become a thing that people use. I guess I'm curious like what your motivations are there.
Yeah, I think one key motivation for using an LLM is just how flexible you can be with the prompts or the specifications you provide it. And I'm hoping that that will kind of uncover what teams are most comfortable providing. Another thing is just like at least with the synthesizers that I've been working with, which are honestly pretty basic, bottom-up, top-down enumerative type synthesizers, the speed at which the candidate programs are generated and the quality of the candidate programs is just miles apart. So those are two of my main motivators.
Makes sense, thanks.
I wanted to ask a question about your longer term thoughts, and in particular, I think you mentioned that in a team, people might have different ideas, right, about what they want, and those have to be resolved. I wonder if I think maybe a naive way to use an existing synthesizer would be to have the team agree on the specification that they want, and then just give that to the synthesizer. But I wonder if there might be value in the synthesizer knowing about the disagreements in the team and sort of using that tension somehow to do synthesis better than it could if those were sort of prematurely resolved.
Right. Yeah, absolutely. Yeah. I think layering like consensus and conflict resolution type stuff on top of a synthesizer would be so interesting. And that was actually what I was like kind of hoping to do before jumping into this user study, but I wanted to take a step back to maybe just see what other things are coming up. Definitely a possible.
So you said you're running a between subject study. Did I understand correctly? It's people who have the synthesizer and versus people who don't. Are those the two conditions?
Yeah, so that's the first study proposal. So between subjects, yeah.
So how will you compare the results?
Actually,
And you'll see a lot of different things.
yeah, so the between would have, so the between one that I proposed would actually have two things going on. You'd have 24 people, half of them would work in groups, pairs of two, half would work individually, and all of them would go through two conditions. They would do one task without a synthesizer and then one task with it. And I think what we would eventually want to compare is the effect of the synthesizer, both on the individual and groups, and then also the impact of like working with the synthesizer or without it in a team type situation.
Okay. Okay, we have time for maybe one more question. Anything else? Okay, thank you so much. Let's give a round of applause.
Thank you for all the questions.